student has decided to measure the density of a stone with a smooth surface but having an irregular shape at home using the following items: a rectangular container, a 30 centimeters ruler, foot ruler with millimeter scale. Assume that he was access to following items too: a household gas measuring cylinder capable of measuring liquid volumes up to nearest 5 milliliters. Electronics balance at the nearby retail shop. Part A. He started the experiment by determining the volume of container using the 30 millimeter ruler. What are the measurements he has to take? There is a rectangular container. It should be cuboid container. Then when calculating volume, we have to measure length, breadth and height of the container. Then we can get answer for A part 1. Length, it is given as x1. Breadth, it is given as x2, and height x3. Part 2. When an ordinary 30 centimeters ruler is used to take the above 3 measurements, one measurement may be less accurate. What is that measurement? It is height. Height, or you can get it is x3. Then what is the reason for that? We know that when considering a container, now we have to consider length, breadth and height, inner length, inner breadth and inner height. But when considering inner height, we know that for the ruler, 0 mark is not at the end. 0 mark is like this. Therefore, when measuring inner height, we have to place the ruler inside the container, and we can't coincide 0 with bottom surface of the container because of this gap. Then we can write the 0 mark of the ruler is not at the edge. Therefore, we can't place ruler such that 0 mark is at the bottom of the container. We can get breadth and height correctly, breadth and length correctly, but we can't get the height measurement correctly because of this gap. In part B, he washed the stone thoroughly, dried it and keep it inside the container as shown in the figure 1. Then he filled the remaining volume of container up to the brim with a measured amount of water used in the measuring cylinder. Let the volume of water measured and added to the cylinder by V. Write down an expression for the volume of stone V0 in terms of V, x1, x2 and x3. We can get volume of stone in the container by subtracting volume of container and filled water volume. then we can get V naught equals to volume of container, length into breadth into height, x1, x2, x3. We have to subtract corresponding water volume. In part 2, if we have an option to choose the container with the same volume but having narrow brim as shown in figure 2. Explain as to why it is advantageous to select such container. When considering a container with a narrow brim, when filling water up to the brim, there is a water volume like this. We know that practically we can't get correctly this, up to this level. There is a water volume above the brim. It is a small one for a narrow tube like this. But for a container like this, there is a large volume of water up to the brim. Therefore, we can write to reduce the water volume up to the brim. It means volume like this. Therefore, volume measurement of water volume is accurate more than this one. In part C, what is the other measurement that he should take in order to determine the density of stone? He has to measure the mass of the stone. Mass of the stone. It is given as P. In part 2, hence write down an expression for the density D naught of the stone in terms of symbols defined above. We can write density equals to mass divided by volume of stone V naught. And we can substitute V naught value as this one. The density, it is given as D naught. D naught equals P divided by, we can substitute volume x1, x2, x3 minus P. In part D, suppose you want to estimate the mass of a huge rock that is situated on a flat land as shown in the figure 3. Using the knowledge that you have gained from the above experiment, assume that you have ability and provision to construct a wooden boxes of any known volume or wooden structure of known size and access to sufficient quantity of fine sand instead of water. Part 1, write down the major steps of method that you would suggest in order to measure the volume of the rock. Now there is a huge one like this in a flat ground. Now we have to use the same method, but we are using sand, not water for this procedure. Then we have to construct a wooden container around the rock like this, and we have to fill the remaining part of the container with sand. If we know the volume of container and sand volume we have used, then we can find the volume of the rock by subtracting volume of container and sand volume. Then we have to write steps. Part D1. Construct a cuboid around the rock. It is the first step. Measure length, breadth and height. Measure length, breadth and height. Then next step, fill the remaining part, remaining volume with sand. When filling, we have to measure used sand volume. Then we can write volume of rock equals to volume of container minus sand volume. In part 2, what kind of measuring device can be constructed to measure the volume of sand using materials given under the above? We can use a small wooden box with a known volume. Normally, we know that in construction field, they are using a wooden box with a constant volume to mix sand, cement, gravel with the corresponding ratio. We can use a box like that. Then we can write wooden box with a known volume. Then part 3, what is the other physical quantity that is needed to estimate the mass of the rock? We have to use density of rock. We can find the density by using a small piece of this rock. And we have to use the previous method in part A, B, C to find the density of rock. And we have to assume that density of whole rock is equal to the density of obtained sample. Then part 4 suggests a method to measure the quantity in D3 above. It means density. We can get a small piece of rock and we can use above procedure. Above procedure means we have to place it in a container and we have to fill remaining part with water and we can find the volume. Then we have to measure the mass of rock. When measuring mass of rock, we have to consider the mass of piece of rock. We have to consider that it is in dry condition. We have to dry it or we can use it before filling water. Then we can find the density of the small piece and we can consider the density of large rock is equal to the density of piece. It means we have to consider that this rock has a uniform density.